Hello, Scryptonauts. All right, you made it to the end of Chapter 2. It's time for a Hello World. But because we're Scrypto and it's asset-oriented programming, we've got a little twist for you. Today's Hello World, we're going to build the Hello token. So we're going to build an actual asset, a resource, and show you how to publish it, interact with it on the Radix engine simulator, and move some things around. So still just like a typical Hello World, quick, simple, but with our good old asset-oriented twist. All right, so with that, let's jump on over to our coding window and get started. Okay, so first up, I just have created an empty directory here on my desktop. You can place the project anywhere you'd like. What I'm going to do is go ahead and open this up in Visual Studio Code. You can, of course, use any IDE of your preference, but we're going to get going here. Now, in the integrated terminal here, I'm just going to run a few commands to get things set up. So as we learned a little bit earlier, we have the Scrypto command line tool, which is essentially a wrapper around cargo, but it adds a few things unique to Scrypto, one of which is the ability to generate a new Scrypto package, kind of the boilerplate code to get us started. And so we do that by typing Scrypto to access that tool. We pass it the new package command, and then we can give it a name. We can name it anything you'd like. It does prefer snake case, so if you do not name your project with snake case, you'll get a little warning. We're going to just name it Hello Token, just like that, and hit enter. And what that will do is generate a simple package for us to get started. Now, if you expand that up, the other thing I'm going to do while I'm here and thinking about it is just now navigate my terminal into that directory. So cd into Hello Token, or whatever you named your project. As you can see, it used this name right here that we passed it to name the directory or folder that was created. And then it generated for us a source folder, which has a Rust file, a test, which we're not going to get into today, but it's there when you get to that point. And then also a cargo.toml, which lists out our dependencies. Now, if you open this up and you're not getting this highlighting, that would be because I'm using an extension. So if you would like to have the pretty colorful formatting, you can come here and get better.toml. That's just adding a little bit of syntax highlighting for that cargo.toml file, which is essentially your manifest of dependencies in a Rust project, or in this case, in a Scrypto project specifically. Because Scrypto is built on top of Rust, we get to utilize a lot of the tools that are available to Rust as well. So we just enhance them and take them a step further. Now, to get into our first Scrypto file, here we go. So open up lib.rs, and this is going to be our blueprint that the Scrypto command line tool generated for us. So as you can see, we've got our blueprint macro, and you'll notice Rust Analyzer down here. This is a extension that we loaded earlier on. Hopefully you already have this right here. If you don't, you certainly will want to get it. So just search for Rust Analyzer in the extension store and get that downloaded. So what that's doing, if we go back to our file here, now we can drop this down out of the way. So this is loading all the dependencies. And as you can see, it's now generated this cargo.lock file. Okay, so what it's doing is it's installing all of these dependencies that we have listed in our cargo.toml, our dependency manifest file, if you will. And this is the result of it. Okay, you don't really need to worry about what's in here. That kind of lives behind the scenes. All we really want to touch on today is our Hello Token component. So this is how easy it is to create a new token on the Radix network, and particularly with Scrypto. If you ever worked in Ethereum, creating a new ERC20 token is quite a process and takes a bit of thought. Here, you can generate a new package which literally gives you a token. So it stubs out some boilerplate code which utilizes the resource builder and calls a constructor for a new fungible, which is a built-in method that we can utilize, and we can add some metadata, etc. And then it sets the initial state when we instantiate this component. As you can see, this is our instantiate function, or you could think of it as a constructor function. And then it also gives us a simple little method here so that we can collect a free token. Okay, so let's briefly touch on what the code is. Since this is our hello world, let's discuss what these things are, and then we're going to jump into the Radix Engine Simulator and interact with this a bit. All right, so to get things started, let's just touch on real quickly. We've gone over some concepts and things, but first go around, I just want to make a quick pass through and discuss what's kind of going on here. So as you can see, this yellow bracket here, this encompasses our entire blueprint. Now, a package can have multiple blueprints, as we've learned, but when they're simple, there's no need. The first thing up, we have our struct and our impl blocks. Okay, so you can see this block here, designated by those purple brackets, and this block here. Okay, so define what resources and data, actually, let's expand on that and say what type of resources and data will be managed by Hello components. Because at this stage, we're just defining what sort of data we're going to have, okay, as we define our blueprint. And then we come down here, and this impl block is implement the functions and methods, okay? So this is where we define the functionality of our blueprint. This is what the components will have access to, be able to do, and then this is the state that will be recorded to the public ledger when we instantiate our component and then interact with that component on a live network. So in the simulator, what we're going to do to get things started is first, we're going to call this instantiation function here and instantiate a component on the network. Now, in our case, we're simulating the network locally with the Radix Engine Simulator, or Resim, but the process is the same on a live network. So when we call this instantiation function, it is going to return a component address, and that will be important later on to access and interact with our component. And then it lets us kind of set things up, do what we want to do. In this case, we're creating a bucket using the resource builder and putting in it 1,000 hello tokens with a symbol of HT. Of course, we can change this, but for now, that's all we really need to know. So at the end, you can see there's this self is setting the initial state. Okay, so we're putting our bucket that we're creating in our instantiator function, and we're depositing it into this vault that's going to be associated with this component. So just like with classes and objects, when you instantiate a new object utilizing a class, we're going to instantiate a new component utilizing our blueprint. And with that, it can have its associated state or its current status, if you can think of it that way. And so that's what we're doing here, is we're setting that initial status. What data is going to go in there to begin with. And then we have, these are built-in methods here, instantiate and globalize. So there's a built-in instantiation method that creates the component on the network, and then globalize actually produces this component address that we need and returns it back to us so that we can then do something with it later on. Now, free token is just going to give us a free token and allow us to collect it at the account that we call it from. Okay, so from here, there's a little walkthrough of the code. We've got a general idea of what's going on. So now let's step over and start interacting with this via the Radix Engine Simulator. Okay, so now to get started with the Radix Engine Simulator portion here. Cleared out the terminal, made a little more room here, and just to make sure we have a clean slate and we're starting off no unknowns, I want to run resim reset, okay, just to make sure our simulator's all fresh and clean. As we can see, we got data directory cleared, and now we not want to generate a new account so that resim new account so that we have a default account that can pay the fees when we go to publish our package here in a minute. Now, we want to store this account address, which you can do in a couple ways. You could store it as an environment variable, or alternatively, if you just want to be simple for the moment, you can also just create a file here, name it anything you want, addresses. Addresses, there we go. And it could be txt. I'm just going to do markdown because then we could do some formatting. But for now, so I'm going to say account address and go ahead and use some backticks here. Oh, although that reminds me, there's some documentation I want to show you. So let's actually copy that and then paste it in. Okay. And there's our account address. We'll want that later when we want to look at the state of our component, which, if you remember, accounts on the Radix network are in fact components. And so since I accidentally pasted that link, let's go ahead and look at the documentation real quick while we're on the subject. So that link was right here. Run your first project. Okay, so if you want to come back later, you're trying to remember how to do something that we covered in this. This is essentially the same walkthrough. You create a new package. It talks a little bit about what things are. You know, you need to create a new account. And also, so with reference to storing it as an environment variable. If you're not familiar with what that is, it's just going to be available locally in the context of your project. So you can store variables in this fashion. So what we can do, now there is a different style. If you're on Windows using PowerShell, then you would want to run this command. And if you're on a Mac, then you would want to run this command. And of course, you want to paste in the account address that you got. All right, so just to know that this is here for reference, you can come back to that later. But there you go. Well, let's jump back to our coding editor now, and I'll show you the alternative. So what we can do is type export account and paste in that account address. Okay, and then what that does is that stores it, as you can see. Let's jump back here. Export account. So this is the type this is what I typed out here. And this is the account address that I pasted in. Okay, that's exactly what we did here. Export account. So this is the command we're giving it. We're telling it to store this as a local environment project, a local environment variable for this project. Okay, and where that comes in handy is in just a moment as we go to inspect that account. So we can type resim show account as we learned previously. Now what this, when I type account here, what this is referencing is this environment variable. And would help. Now when you call on that, You need to actually give it the $sign. Okay, so let's expand that up. Now, so you now know how to store an environment variable and then, well, correctly utilize it by giving it the $sign. And what that gives us is the information about our default account that we just created. As we've seen before, we get 1000 XRD. So now what we want to do, this is the initial state of our account component. So now we want to publish our package and see if we can't get our free hello token. And then we'll come back and inspect this account to see the results, to make sure we were successful. All right, so I guess we can go ahead and leave that large and move on to our next set of commands. Okay, so up next, we want to publish our package. Now, there's a couple steps to this. First up, we need to generate a badge for our component owner, so our package owner, I should say. So what we're going to do, we have a command for this in Resim, and we're going to type Resim new simple badge. Okay. And as you can see, again, it gives us a resource NF address, non-fungible address. Okay. And this is going to be important in a minute when we publish our package. So why don't we once again export badge. Actually, we'll just name it badge. And we want to grab this right here and paste that in. Okay. So now to publish our package, we need to pass it a flag telling it who the owner is going to be. And that's what we're going to use this badge here for. Okay. So when we want to publish a package, okay, we're going to type resim to get to the tool. And then we're going to use the publish command and tell it dot, which is just telling it to publish everything in our package here. You can be more explicit, more specific, but for our purposes here, this will work just fine. And then we want to use the --owner -badge flag. Okay, we're letting it know that we are fixing to pass it an owner badge, and we want our package that we are publishing to be associated with that badge. Okay, and then we're just going to give it our variable that we created of badge. Okay, and we'll run that and publish our Scrypto package. Okay, so this may take a minute. It's going to publish some things. As you can see, it's compiling, it's building things out. And when it gets done, then we can go interact with our published blueprint package. Okay, so the next step from here, we'll be able to go in and instantiate a component. So right now, we're publishing this package out here. We're publishing the set of plans that enables users or other components or whatever the case may be to come and create new instances utilizing this set of plans. So with that, we got a success, new package, and here is our package address, which I'm just going to store again as an environment variable, package, and copy that in. Okay, so we got a whole bunch of stuff. As you can see, it compiled everything and published our package. So now we're going to need to move on to instantiating our component. Okay, so I'm going to clear this up just to give us some room to work here, and we'll move on to our next set of commands. Okay, so we've got a clean slate here. Let's make some room and let's talk about what we're going to do next here. We don't need this anymore. In fact, let's talk a little bit about, we've got our package published to the network. What we want to do now is come in here and call this instantiate hello function. Okay, so just for reference, let's jump back out to the docs for a second. Now, if you can't remember the format of the commands, you can come to this cheat sheet right here. And as you can see, there's our Scrypto commands and our Resim commands. And what we want to do is call a function. Okay, so let's look down this table here to call a function. We want to use Resim, pass it the call function command, and then we've got some arguments that we need to give it. Okay, so we stored our package address, which we're going to pass in right here. We also need to pass it our blueprint name. Okay, so our blueprint name is hello. Okay, this right here. This is our blueprint name. Okay, so whatever you name this here on your struct and your impl, which should always be the same, is what you're going to pass as a reference to that tool. Then from there, we need to pass it the function that we want to call, and if there are any arguments, the arguments that go with that function. Okay, so this right here, in our case, is just our implementation or instantiation of our hello component or our hello blueprint, but this is what will instantiate a component. Okay, so let's do that. Let's type resim call function, and then see, even I have to go look. The order was package address. Okay, so let's give it our package environment variable that we created. And then what do we got? A blueprint name and our function. Okay, so our blueprint name is hello, so we just need to pass hello. And then the function that we want to call is instantiate hello, which does not take any arguments in our case. So we just pass instantiate underscore hello. Okay, so there you have it. We're using Resim. We are calling a function, and then we're passing it a package address, a blueprint name, and the function that we wish to call. Okay, so we run that. We get a committed success. So we did, in fact, instantiate our component. And we also get back two new entities, so which are, most importantly, our component address. Okay, so this is our instance of the hello blueprint on the network. In our case, it's a local network on the simulator, but the same happens on the live network. Okay, the second resource address that we've got here is going to be our token that we created. It's how we're gonna, what the identifier is for these non-fungible tokens, these fungible tokens that we created. So they're all the same, they're tokens, so they can be referenced by a single address. You know, they all have an equal value. So now what we can do is go get a free token and interact with it. Now, as you can see, the other thing we get is a list of the things that went on behind the scene, the instructions that were used by Resim. And some of this is created for us as a convenience by the simulator so that we don't have to do all this at our testing time. But as things progress, as you move along in the course, this will come up again when you get to transaction manifests. So this is the set of instructions that gets composed to interact with the network, to do things, to move assets around. So just know you don't need to get into detail on it yet, but there's more details to come, and that's what some of these things are. So, if you're wondering, well, where did these call methods come? How did it come up with this? Well, that will come in time, and as you get into the chapter on transaction manifests, we'll cover that. So, all right, we have an instantiated component. So now let's move on to the next step. Okay, so next, before we move on, let's go ahead and store that component address so that we can use it when we want to interact with it. So what we're going to do, again, export component equals, and we want to copy this right here. Okay. And of course, you could do that in this text file if you don't want to store them as environment variables. I just find it convenient. So now that we've got our component address, we've got an instantiated component, we have an account to interact with, let's go ahead and call our free token method. Okay, so very similar to how we instantiated, but this time rather than call function, actually we need resim. Instead of call function, we are going to call method, because this time we are going to mutate state, because we're going to take one of those tokens from the initial supply created for our component, which lives in the components vault at this point, and we are going to transfer it to our account. Okay, so what we want to do is resim call method, and then we're going to pass it the component address so that we know which instance we're interacting with. And we can do that by referencing our component address here. And then we've got to tell it what method. So in our case, it's free underscore token. Okay. And again, no arguments in this method, so we were just going to go ahead and run it. And there you have it. We have successfully executed a method on our instantiated component to get a token. All right, it's that easy. So not only did we get the creation of a token, but transactions are extremely simple. So there's just a lot of standard interactions that have been handled for us by the Radix engine and the Radix network that would take mountains of effort to get to on other networks like Ethereum, for instance. So very exciting. This is quite a powerful hello world. So you are well on your way to revolutionizing DeFi. Okay, so let's talk a little bit about what we got back when we called this method and what went on here. All right, so we can see there's some transaction fees for making this transfer. Okay, we see this log, this info. Okay, we saw how we can output logs. This is an info log, and it's passing the balance of the component. Okay, so it says I've got 1,000 hello tokens. Now giving a token away. And then again, we have a transaction manifest that kind of happens for us behind the scenes thanks to the simulator. We get a bucket. And so now let's inspect our account. Okay, so resim show account. Gotta remember that $sign. Okay, so now let's expand that up so we can see a little more. Here we are here, resim show account. And so it gives us back some data about our account. So as before, we had our XRD down here. Okay, but we now also have two more things, because when we published our package, if you remember, we used the resim new simple badge command, And that returned us back a non-fungible badge. So as you can see in our resources for this account, we now have that non-fungible badge, as well as up here, we have our hello token that we just transferred with our free token method. All right, so pretty powerful. In just a simple hello world, we have created a token. We have created a non-fungible token. We have created, a non-fungible badge, a fungible token, and we've transferred it to an account from a component. So that's probably a lot to chew on for a hello world. I think maybe we can think about wrapping it up there, but pretty impressive. Congratulations for making it to the end of this chapter. You have hit the exciting part of your journey where you're starting to write Scrypto code, and you can begin to think of all the new exciting applications that you can build with your creativity, because it takes away all the boilerplate that you would have to build. So this is why Scrypto is so exciting. This is why the release of this network is going to empower DeFi in so many ways. So congrats. I hope you've enjoyed. And after this, we'll do a little wrap up and give you a few pointers on how you can take next steps and expand your learning to the next level to progress from here. Okay, so just a quick wrap up, just to go over real quick what we've done here, what there is to kind of pay key attention to. Of course, you can play around with this further. You can add more methods. You can do what you want. Now, a couple key points of reference. There were two pieces of documentation that are important. One is this CLI cheat sheet here. Of course, all your commands you can come back to, as well as this one right here, which has a little diagram and gives you further. Now, if you want to walk through this again, just with the written version, this is in the documentation here. Okay. Run your first project under Building Scrypto, and there's additional explanation, etc. Okay, so if you want to run back through it again, here's some key points of reference, and then that should do it. So congratulations, you've made your hello token. It's time to move on to the next chapter and get into a little more detail as to what we can do with resources and all the built-in functionality of the Radix network, and get you on to building the next generation of finance. Thanks, everyone. See you in the next one. Bye-bye.